All right, this is the third time I've recorded this. Uh, Good morning, good evening, good afternoon, whatever. This is Harry from Web422. Today we're gonna dive into the reason why I recorded it multiple times. I have a hard mute button on my headset and I pushed it by accident halfway through. So anyway, this might be a faster lecture because it's the second time. Today we're gonna talk about um. We better not show my screen. Hold on. Today we're gonna talk about um optimization, right? So optimization for our sites, analyzing the performance of websites, and specifically something that Google imposed called Core Web Vitals. You've probably heard me say that Next.js I think is it's super fast out of the box, but I also think it can be super slow. Depends what you're using it for, and there are a lot of automatic features that keep it fast, like static optimization and route prefetching, and um, but even with those tools, it's critical that we actively measure and monitor and fine tune our code to get every millisecond of performance out of it. And the reason is because um, this matters for user engagement, SEO impact, conversion rates. So conversion rate in the web, if you don't know, is when someone does an action on your site, whether it's purchasing something or you want them to interact with something or log in. Those would be conversion rates. So we're going to look at core web vitals, which is from Google, what they are, why they matter. Talk about Lighthouse, which is Google's kind of auditing tool, and then I'm going to show you a demo of this kind of stuff running. It shouldn't take too long. I would watch the rest of this video. I know it's going to be 20 minutes, but it's worth it. So back in 2020 of May, 5 years ago, it's crazy. Google rolled out this a subset of their metrics. So they've had metrics for years, right? You pop them into your website, you can tell how many people visited a page, how fast the page loads, etc. But they rolled out this thing called Core Web Vitals, and these are measurable signals that capture key aspects of the user experience on any website. So basically, what they tell you is your website fast enough to load? Does it pass all the SEO tests? How does it work? And the unfortunate thing, well, I guess maybe it's fortunate, unfortunate. Unfortunate for users, unfortunate for developers, is that Google has also integrated this as their page ranking experience. So you can't basically get into Google search without following the core web vitals. And it sucks for us because everyone uses Google. So core web vitals are three metrics: largest contentful paint, and I'm going to describe what these mean in a second. First input delay and cumulative layout shift. I don't know where they come up with these words, but um, these reflect real world loading, interactivity, and visual stability. So, largest contentful paint. This is the LCP right here. And this means that it measures the time to render the largest element in the viewport, right? So, it's not unlike your video games. So when you tweak your video games and say you're running, I don't know, Grand Theft Auto and it's running at 40 frames per second, and you do some optimization to your system, and now you get 60 frames per second. This is very similar, a similar theory. Let's see how fast we can get things to render, right? Because this is a render engine, just like a video game. How fast we can get stuff to render on the page. So, when you visit a website, CNN.com, I don't advocate for it, but you see how fast does this page load? And do I, as a user, do I wait for it to load before I do stuff? So you can see kind of glitches around. This ad's not loading very fast, right? How fast does that happen? So we can measure this. Typically, the faster the page loads, the more the user will interact. Walmart increased their load time by like something, I don't know, by 100 milliseconds, which seems like so small, and it increased their sales by 1%. Pretty crazy. All right, so that's LCP, and then we have FID, which is first input delay. So this is the delay between when a user's first interaction happens and when the browser begins to process event handlers. So when I click on something on the page, that time and it how that time that the page reacts to whatever I click on. So this is basically called responsiveness. that the page how responsive the page feels on the initial load, and the target for this is under 100 milliseconds. Well, I mean, can we even perceive under 100 milliseconds? I'm not sure. The next one is cumulative layout shift. This measures the total of all the unexpected layout shifts during the page's life cycle. So basically, this presents frustrating jumps that cause misclicks. Now, I don't want to say this happens all the time, but on CNN.com, for example, doesn't I haven't really seen it happen. But this would be like, let's see if I can find it, if I can make it do it. Let's say this column was loaded and this column right here was not loaded, and or sorry, this middle column was loaded and this one wasn't. Let's say, and then this, this link I'm about to click on, and then something loads over top of it. Actually, here's a better example. I'm not saying that I've done this or you should do this, but if you're on Pirate Bay or one of these websites and you're about to click on a torrent file, don't do that. Don't download movies. If you were about to do that in theory, and then all of a sudden you go to click on it and an ad pops up over it, they intentionally do that, right? They track how long your mouse is there, estimating you're going to click on it. That's a cumulative layout shift. So that's it's kind of they want to track for that. So Google's determined that these three metrics are like the most important, and there's a way to track them. So now we know which metrics we can measure, but how do we actually measure them? So Google invented this thing called Lighthouse, and Lighthouse we can do right from Chrome DevTools. We can do it inside of a node module. We can do it in GitHub Action. And the reason, like, we'll show some easy ones. So if you go to any web page, CNN.com, for example, right click, go inspect, click on Lighthouse, and then I picked desktop because that's the system I'm on. I'm going to click Analyze Page. I'm going to pause this, and you'll see. So this is now analyzing. It's going to give us our metrics for those three items, basically called an audit. There's that Walmart quote that I was talking about. So here's the report on CNN site, which is pretty poor actually. It says performance at 52, accessibility 82, best practices 56. Their SEO is great because obviously they are wanting to get Googled, right, or in their index. But you can go through this report, and we can run Lighthouse on any site, right, on any page, and it will tell you what we could or need to improve. And here's like the first contentful paint, um, largest contentful paint, cumulative layout shift 0, and it tells you how long it loads. Things like this. It's kind of cool. So what we want to do, and obviously this is only running it on one page. I would have to run it on every page to get a whole website overview, and this is why Lighthouse is actually available as a node module or page speed insights, or even in the node CLI, and it can run it on all of your pages. We're just going to look at this dev one right now. So anyway, back to this. So I'm going to run it on our demo code, and I went and downloaded it from our example stuff down here. You can see our example code, and we'll just do npm install, and then we'll do npm run dev. So we'll run our code, and then I'm going to go to Lighthouse and see how great our code is or how not great it is. So here's our score. It's 48 performance. The other stuff's not been too bad because it's just one page. It's really not that crazy. But the performance is pretty low, right? So this is saying we can decipher some of this stuff. It says basically 1.2 seconds to load the entire page. And a low LCP means that we should look at critical things like CSS and lazy loading large images. I'll come back to that in a second. Or server-side rendering. A high FID on production often points to heavy JavaScript bundles. And the heavy JavaScript bundles block the main thread on your computer, right? So then we should consider dynamic imports or even web workers. A high CLS score signals, user layout shifts, like I was talking about on, Pirate Bay, things like that. Don't go there. Don't go to Pirate Bay. And but look, let's look at some stuff that we can change. So I'm not going to go into every detail of this. You can go and look at this if you want to, but I show you some of the major items. So if I check out our code, let's see, where did it go? Not this one. So I'll just blast through some of these really quick. You'll notice that here's our index.js file, right? And if you look down here, you even see inside of Visual Studio, it's highlighted already, and it says Using image could result in a lower LCP. Now, hey, now we know what LCP is, which is neat because I never knew what that was before. Well, you guys didn't. And it result in higher bandwidth. Consider using image slash from next image and to create a custom image loader that automatically optimizes images. So it's saying, hey, don't just serve your JPEG right to the user from your public index file. It's saying, hey, we have a library that you can use that will allow us to optimize your images already for you. So there's some examples you can do. We'll replace this one real quick manually just to show you. So I would actually import the Next.js image module, and then I'd grab the image code instead of doing this one. We would do this, and it's basically the same, right? It's saying use the theater background image.jpg, call it whatever theater background, but instead of it loading it right from public HTML or public folder, it's going to process the image for us. Maybe it'll do some compression on it. It'll be, might be better. So that's one of the things. Now check this out too. We have something called lazy loading available to us. Anyone know what lazy loading is? I shouldn't say does anyone because we're not a live video, but lazy loading is a design pattern that delays the loading of non-critical resources until they're actually needed. So instead of loading all of the JavaScript up front, we just hold off on doing certain things, like even hold off on downloading images or scripts or components that aren't like immediately available. So, pardon me. So an example of this is check out the um, filtered results. Actually, this is, I don't want to be inside of here. This one. Check out our filtered results inside of index, which is right here. Right, so we load in Lodash from our module folder, but we don't use Lodash until we actually use filter results. So what's happening is we're loading this entire JavaScript library into the user's browser, but we haven't used it yet. So we can lazy load this in by saying, I'd like to just only use um, the Lodash when our filter results is happening. So I can paste this code in, I make it an async function, and there's our Lodash right there, and I can take it away from here. And this should increase the performance on our page. So we can do a couple things like this to increase performance, and I'm going to show you that just with those two changes, we'll go back to our optimized version, and then npm, let's, I think cd my app, and then npm install, and run the dev site, and we'll refresh our page. Oops, right here. Then we'll do Lighthouse on it, and let's see if we can beat 42%. And here it comes, up to 81. That's awesome, right? 40, almost 42%, 40% increase, 39% increase, just by changing a couple of those things. And I don't particularly like Next.js and React because it is heavy on the user side of loading your website, meaning your user's computer has to be quick in order to load your page. Next.js kind of takes away a little bit, but the biggest thing that can to improve this is server side rendering. And server side rendering is like straight up the browser is not doing any of the work. All it's doing is rendering the HTML as opposed to running the JavaScript code and then running the HTML. Think of it like if you had to run Grand Theft Auto and you had to run the source code, meaning you couldn't compile Grand Theft Auto, and you had to run it the source code on your computer to run the game. Imagine, well, I'm telling you how slow it would be. You probably wouldn't even be able to run the game because it would run the code line by line, right? That's how JavaScript works. Now, if we compile that, I'm sure then we can now run the game super quick, 60, 90, 120 frames per second. Same thing kind of happens with JavaScript. If we take everything that the user requests and render it as HTML and not worry about the JavaScript, the page will even load even faster. So that's another way. We call this SSR, server side rendering, and we have an example of this too. So I'll just open this up, and I'm not sure if we'll see improvements here. We might. Let's check out. We'll see if we do. We'll run it anyway. It might not matter in the dev mode, but maybe in production mode, it might make a difference. Let's just take a look here. I'm not sure if it will, but we'll try it anyway. Anyway, so with a few of these things, really it can help improve. Well, we had at least we got a 1% increase. It's still, it's still something, right? And this can be way better on larger projects. But we do want to take a look at this stuff, right? So I think server-side rendering is probably the fastest. I know it only gives us a 1% gain here, but in other scenarios, it would give you much faster or much more gains in server-side rendering. And you can enable this again. I'm not going to go through all of this with you. You can look at it, but you can actually go through this and easily look at some of these tweaks. Anyway, it was a crash course in the um, the web vitals, the core web vitals from Google, and how to increase performance in your apps. The faster your app on either whether it's a game or a phone app or wherever, the better your user will like it, and the more happy they are, the more chances that they're going to buy something. Anyway, have a great day.